Hello students, welcome back. In the last lecture, we have done the formulae of inverse function and the theorem of inverse function. Alright, now in this lecture, we will be doing the examples of inverse function. Okay, let's move ahead. The first example, differentiate with respect to x cos inverse of 1 minus x square. So let's see how we are going to do it. First of all, we will be considering y equal to cos inverse of 1 minus x square. Differentiate with respect to x, dy by dx I can write as ddx of cos inverse of 1 minus x square. So over here I will be applying the formula of cos inverse of f of x. What was that? That is minus 1 upon root of 1 minus x square whole square and the derivative of 1 minus x square. Okay, so again we have taken the derivative of 1 minus x square. Then I can write this as minus 1 upon root of 1 minus x square whole square into minus 2x. Derivative of 1 will be 0 and derivative of x square will be 2x. And over here I have minus sign, so I will be writing minus sign over here. And in the numerator I have minus 1 minus 2x, so I can write this as dy by dx equal to 2x upon root of 1 minus x square whole square. So this will be the answer. Let's see next example. Differentiate with respect to x cos inverse of root of 1 plus cos x upon 2. So how we will be doing this question? First of all, we'll see the sum properly. Cos inverse of root of 1 plus cos x upon 2. So can we apply any formula over here? Yes, we can apply. Let's see which formula. Consider y equal to cos inverse of root of 1 plus cos x upon 2. So I can apply the formula of 1 plus cos theta, that is 2 cos square theta by 2. So I can write y equal to cos inverse of square root of 2 cos square x by 2 upon 2. So this 2 and this 2 will get cancelled. I will be getting y equal to cos inverse of root of x square cos square x by 2. Okay, over here we have square and also we have root, so they will get cancelled and I will be getting y equal to cos inverse of cos x by 2. And everybody knows that cos inverse of cos theta will be theta, so y will be x by 2. Now we will be differentiating. So differentiate with respect to x, dy by dx will be ddx of x by 2. So that 1 by 2 I can take it out and I can write this as half ddx of x, and derivative of x will be 1. So dy by dx will be half. Okay, so this will be the answer. Let's move ahead. Next example, differentiate with respect to x. Tan inverse of 1 minus cos 3x upon sin 3x. Over here also I can apply the formula. Okay, so which formula we will be applying? Let's see. So y equal to tan inverse of 1 minus cos 3x upon sin 3x. So in numerator, I can apply the formula of 1 minus cos theta, that is 2 sin square theta by 2. And in denominator, sin 2 theta, that is 2 sin theta cos theta. So we will be writing y equal to tan inverse of 2 sin square 3x by 2 upon 2 sin square 3x by 2 into cos 3x by 2. So 2 will get cancelled, and from numerator 1 sine 3x by 2, and from denominator 1 sine 3x by 2 will get cancelled, and we will be getting sine 3x by 2 upon cos 3x by 2, and that is what? Tan 3x by 2. And you all know tan inverse of tan theta will be theta only, so y equal to 3x by 2. Now we will be differentiating. So dy by dx equal to ddx of 3x by 2. As 3 by 2 is constant, so I can take it out, and derivative of x will be 1. So derivative will be 3 by 2. So this will be the answer. Okay. So these type of examples, they are in board, they can ask for 3 marks. So where I have applied the formula, that step will carry 1 mark. Then where I have got y equal to 3x by 2, this step will carry 1 mark. And the last answer, writing last answer in board exam, it's very important because that carries marks. Okay. We'll see next example. Differentiate with respect to x tan inverse of cos 7x upon 1 plus sine 7x. So how we are going to do it? Let's see. Consider y equal to tan inverse of cos 7x upon 1 plus sine 7x. So in numerator, we will be applying the formula of cos 2 theta, and denominator we will be applying the formula of 1 plus sine 2 theta. So what is the formula? Tan inverse of cos square 7x by 2 minus sine square 7x by 2, and denominator will be cos of 7x by 2 plus sine of 7x by 2 whole square. Okay, so the numerator will be in form a square minus b square, and the denominator will be a plus b whole square. So I can write the numerator as a plus b, a minus b, and denominator I can write as a plus b, a plus b. So in that form only I have written cos 7x by 2 minus 2 minus sine 7x by 2 into cos 7x by 2 plus sine 7x by 2 upon cos 7x by 2 plus sine 7x by 2 into cos of 7x by 2 plus sine 7x by 2. So this plus will get cancelled, and we will be getting y equal to tan inverse of cos 7x by 2 minus sine 7x by 2 upon cos of 7x by 2 plus sine of 7x by 2. Now over here we have to divide the numerator and denominator by cos 7x by 2. Okay, so we will be getting y equal to tan inverse of 1 minus tan 7x by 2 upon 1 plus tan 7x by 2. So we can relate this with tan inverse of x minus y upon 1 plus xy. So how I can write? So over here we have 1. So instead of numerator 1, I can write tan pi by 4. What is the value of tan pi by 4? It's 1. But denominator 1 I will be keeping as it is because I have to convert this into one of the formula. So I can write this as y equal to tan inverse of tan pi by 4 minus tan 7x by 2 upon 1 plus tan pi by 4 into tan 7x by 2. So this is which type of formula? Tan of a minus b. So I can write this as y equal to tan inverse of tan a minus b. So tan inverse of tan theta will be theta only. So y equal to pi by 4 minus 7x by 2. Now we can differentiate this function. So differentiate with respect to x, we will be getting dy by dx equal to ddx of pi by 4 minus ddx of 7x by 2. As 7 upon 2 is constant, so I can take it out, and derivative of x x will be 1. So I can write this as minus 7 by 2. So your dy by dx will be minus 7 by 2. Now we'll see the next example. Differentiate with respect to x, y equal to cos inverse of root 3 cos x minus sin x upon 2. So how we are going to do this example? We have to apply over here one of the formula. Which formula? Let's see. Y equal to cos inverse of root 3 cos x minus sin x upon 2. I am bifurcating this 2, so I can write this as y equal to cos inverse of root 3 upon 2 cos x minus 1 upon 2 sin x. Okay. So I am substituting root 3 upon 2 as cos alpha and 1 upon 2 as sin alpha. And I can write alpha as cos inverse of root 3 upon 2. We'll see why I have substituted cos alpha. See here, y equal to cos inverse of cos alpha cos x minus sin alpha sin x. So that I can write y equal to cos inverse of cos of alpha plus x. Okay, and cos inverse of cos theta will be theta only. So I have written y equal to alpha plus x. Now over here, whatever we have substituted, okay, over here I have substituted cos alpha is root 3 by 2 and alpha will be cos inverse of root 3 by 2. Whatever we have substituted, you have to re-substitute over here. Okay, so alpha will be what? Cos inverse of root 3 upon 2 plus x. We will be differentiating, so dy by dx will be ddx of cos inverse of root 3 upon 2 plus x. So I have applied the one of the rule of differentiation, that is addition over here. So derivative of constant, this is constant, no variable over here. So I can write that 0 and derivative of x with respect to x will be 1. So dy by dx will be 1. Alright, so I think you have understood how we can solve the example of inverse function. Okay, so as a homework, you all can take the examples from exercise 1.2, 6 and 7. Okay, you all can try it out, the examples of exercise 1.2, example number 6 and 7. Okay, thank you students.